As a general tip also, if you want to do anything to do with timing something out and having things coincide or be offset or whatever, try using a timeline, because a timeline can use any gadgets in it and it will just power and unpower at the right times. So if you can even use this for pulses, for example. So if I use L1 and right to expand this, you can actually see the individual logic frames of this timeline. That is if you leave it on 100% speed. If you change that, then it starts kind of getting wonky. But if it's on 100% speed, these represent actual frames of logic. So you might think if you want to have a pulse like at this point in the timeline, then you can put that through a signal manipulator and have that in pulse mode, because that's how you do pulses. So a pulse is actually just an on signal for one frame and then an off signal. So if we use a calculator and then a value slider, and we can wire that in there, we can actually wire the result into B or A, and then it will just add itself to itself. So if you set this to 0.1 to 0.01, then it will be adding 0.01 every logic frame for as long as it receives that value. So if we wire that into there, we can see how many frames of logic the pulse runs for that it's on. So if we play, so it's just stuck at 1 now, and that's what a pulse is. So and use it to like trigger logic and things like that. But you can actually remove the signal manipulator and just make this last for 1 logic frame, which does exactly the same. So now if I wire that into there, play time, then it added 1 because it ran this switch for 1 frame and that's it. And you can do the same for like pulsing a keyframe or sending a signal or whatever you want to do. But the advantage of this is you can have lots of different pulses and signals all working without having to have lots of signal manipulators. So maybe you want a pulse to happen there, and then there, and then there, and they all go to different places for whatever reason. Then you'd need the actual triggering switch in the right time and a signal manipulator for each of them, like that. But with this method, you can just make them real thin, make them each last 1 frame, and then they'll just do their thing. And this could be a tag that's detected by a trigger zone that triggers some other logic somewhere else, or these could lead to different things within this logic. So a timeline is very useful for logic things like that. It's also useful for having like an end state after an animation. So let's say, let's just make a little animation. Then those will flash those colors at the right times. At the end, maybe you want it to stay glowing, as simple as that. So you could change it to keep changes like that. Or you could drag the end off the edge and then power this. This will probably be triggered by some logic or other, presumably. So if I use a switch to represent it being triggered, so if I just keep on powering it, it will get to the end and keep on powering anything that's hanging off the edge. So you can see it has this kind of little transparent bar going up and down. This is the area that is actually activating, so it's just to the right of the playhead. But because this actually hangs off the end, it's still to the right of the playhead, so it's still being powered and still glowing. Now this could be for different logic though. What if we wanted to have this turn on a mover or a rotator? So the rotator would be in here, and it's already nice and long. So have it affect the cube. So it will flash those colors and then it will start rotating. And it will keep rotating because we've still got it powered. Like that. So you can have any kind of logic in here that has some steps, and then has a final state at the end. So another thing you can use it for is to lock into place a random value. A signal generator can generate random values. If I just change, this is when it goes up to a value, it will go to a value within this range. So if I set that to 0 between 0 and 1, then it will be a random value within that range, and then same when it goes down. So now we've got random values, but then if we put on sweep second 0, it will keep on giving us a different random value every frame. So let's say we want to just generate a random value and then lock it in. You could use a signal manipulator and just wire it in and wire the results into there. So if you turn on freeze, it will freeze the output and just store it forever and keep on outputting it until you unfreeze it like that. But if you start it frozen, you really want it to just grab the first random value. So if you start it frozen, it actually freezes at 0 instead of at whatever the value is coming in. So what you can do is use a keyframe on here to freeze it instead. So normally it's off, and then when it gets to this keyframe, it will turn it on. And we can just turn that to keep changes. So let's just see if that works if we put it back there. So now it's locked in forevermore like that. But we don't actually need this to keep on running while it's after it's frozen. So if we just put that into the timer, into the timeline, then we can have that last for 1 frame maybe. Let's run that. Yeah, so it needs to last for 2 frames so that it doesn't go, once this is unpowered, it will be sending 0 into there. So we need it to keep on powering through that. And now on the second frame, it gets its random value and locks it in. So let's say we actually use that for something. Maybe we use it in here to affect the hue cycle. We'll just wire it in from there. So it will multiply that by the random value, so it will be a random color. So it's tinting it purple, a lot of purple, and then green, and so on. So this is kind of a way of generating a random color out of like all available colors basically within 2 frames, but you don't want it to be seen until, like if you play time, it'll start off as red every time. When you emit it or when you just power it, then it flashed a different color before it settled on the real color, which doesn't look so good. So maybe you want to have it start off as being invisible and then sort its color out, and then I'll just use a switch, for example, at the after that point like that, and plug that into the visibility of the cube. So now when I turn it on, you won't see it. You will see the microchip, but you won't see the actual cube until a frame once the color is sorted. So you don't see that weird red flash. It just loves purples. And because it's powered by this wire coming in, it's still going to stay on whatever state it is at the end, and all of the stuff before it won't be powered, which is good for performance. Alternatively, of course, in this case, you could use that to make it visible, and it would do the same thing. But that means that you can have like a whole load of animations and very complex, like frame by frame setting up of logic and calculations, and then have this end state all within one, which is pretty cool. I'd like to thank MDKD99, Kolwitzer, Scully Volley, and all of my other supporters that make these tutorials possible. Check out TAPgiles.com to find out how you can support me in helping Dreams creators. Thanks for your consideration, and I'll see you in the next one.